Hi friends, in this tutorial we will be dealing with the elongation of a bar with varying diameter. We have a bar like this, and this is a 3D view of the bar. So this is the bar. It is having a diameter of D1 here, and it is having a diameter of D2 here. We need to calculate the total deformation. Total deformation, that is delta. This is the question. Okay. Since this is a having varying cross section, the area will be varying, and we have to calculate the deflection for the very infinitesimal part first and then integrate. Okay, so we have, let us take it the cross sectional view like this. It is D1, it is D2. Okay, so we have to calculate the deformation of very infinitesimal member and then integrate this from the 0 to the whole length. Okay, so let us find out what is the deflection of this infinitesimal member. So let's suppose the small deflection or deformation delta is equal to, we have the equation p into dx by a into e. Okay, so this infinitesimal part is having dx length, and this whole member is having an a modulus of elasticity as E, and the area, this is area is varying, so let's take it as ax since it is varying with respect to x. So this delta is equal to p into dx divided by a into corresponding x into E. Now the total deflection, that is delta, is equal to integration of this small delta. Okay, so total integration of the delta will give you the total deformation of the member. So the limit will be from 0, which is, if you start x from here, the limit will be from 0, the x value is 0, to the end point, that is up to d2, that is when x is equal to L, small letter L. How we can take this? Because of this is the length, small letter L is the length of the member. So we have delta is equal to integration of, what is this delta? It is equal to p into dx divided by ax into e. Okay, so since the p and e are constant, because the only one force is acting and the material is made up of same material, so p and e are constant, let's take it as outside. Delta is equal to p by e into integration up to 0 to L dx by ax. But what is the value of ax? What is the value of ax? Is equal to area of the circular cross section, that is pi by 4 into the diameter of the circular cross section, that is dx square, where this is dx, this dx is in here, this is the strip, the diameter of the strip is taken as dx, diameter of the strip is taken as dx. So ax is equal to pi by 4 into dx square. So put this in the integration equation, the value will be p by e into integral 0 to L pi by 4, sorry, dx divided by pi by 4 into this dx square. Don't confuse it with this. Dx is the diameter, corresponding diameter, and this dx is the infinitesimal length. Okay, so this dx and dx does not get confused. Okay, so this value will become pi by 4. This will become 4p by pi e taken as outside, integral 0 to L dx divided by dx square, dx divided by dx. Now how can you find out that dx value? That dx value can be found out by, so this is your tapered bar, this is d2, this is d1. Okay, so this is dx, this length is taken as x. Okay, so what this, the dx will be, dx will be d1, it will be d1 plus. Okay, by using simple trigonometric function you can find out that. We will find out very simply here. Okay, d1 plus, what is the difference, total difference between d2 and d1, that is d2 minus d1. Okay, this, the total difference is happen when the length becomes from 0 to L. When it comes from d1 to d2, the length became 0 to L, and this total difference happened in that L. So divided by that total length into up to dx, what will be the difference? This is divided by L into x. This is the value. So dx is equal to d1 plus d2 minus d1 divided by L into x. So now the equation will become 4p by pi into e into 0 to L dx divided by, so that dx is equal to d1 plus d2 minus d1 into x by L. These can be taken as small l, because we took it as the small l. X by L, x by L, this is whole square. We can write it as, this is equal to 4p by pi e into 0 to L dx divided by d2 minus d1 into divided by L into x plus d1 whole square. Okay, so what is that integration? How can you do that integration? We have the integration formula of 1 by ax plus b whole raised to n, 1 by x plus b whole raised to n dx, integral of this is equal to minus 1 by a into n minus 1 into 1 by ax plus b whole raised to n minus 1 plus c1. This is the integration formula. Here you have the lower limit and upper limit, so this constant will be cancelled out. So in general there will be constant, but here since there is an upper and lower limit, the constant will be cancelled out, and the n value here, this is in the form of ax plus b, where a is equal to d2 minus d1 by L and b is equal to d1. Okay, so here an n value is equal to 2. So in this case, for n is equal to 2, the equation will become minus 1 by a into, that is minus 1 by a into 2 minus 1, that is 1, into 1 by ax plus b whole raised to 2 minus 1, that is ax plus b again. Okay, so we can substitute for a and b here. We have a is equal to, what is the value of a? The a value is d2 minus d1 by l. This is equal to minus 1 divided by d2 minus d1 divided by l into 1 by the a again is equal to d2 minus d1 divided by l into x plus the value of b is d1. Okay, so you have the integration equation as like this. Okay, so apply the lower limit and upper limit. What is the lower limit and upper limit? The lower limit is 0 and the upper limit is l. Okay, since this minus 1 by divided by d2 minus d1 by l is constant, you can take it as outside. Then you can take it 1 by d2 minus d1 by l into 1 by d2 minus d1 by l into x plus d1 from 0 to l. So this is the equation of integral 0 to l and the integration part. Okay, so this equation will, when you apply the lower and upper limit, you will get minus 1 by, or you can take it a minus l divided by d2 minus d1 into, first apply the upper limit is l. The what is the value l and l? When l comes here, l and l cancel out, and d2 minus d1 plus d1. Okay, so there will be 1 by d2 will be there, and then minus apply the lower limit. The lower limit is 0, and when you apply the lower limit, there will be only this part will become 0 and only d1 will be there. Okay, so this is the equation. Now take the LCM, so that d2 into d1, put d1 also here. Here d1 into d2 into d2, so that you can take the LCM, and d1 d2 is the LCM. So the value will become, this is equal to minus l by d2 minus d1 into d1 minus d2 divided by d1 d2. So this minus will go inside, and this will become minus d1 plus d2. Okay, so the d2 minus d1 here also, and d2 minus d1 is here. So these two terms will cancel out, and the remaining term will be l by d1 d2 will be the remaining term. But is this the final value of delta? Delta is not is equal to, delta is not is equal to L by d1 d2, because delta, when we apply delta, when we calculate delta, we have used this 4p by pi e, we have already taken outside, and now this L by d1 d2 is the final answer of this integration part only. So we have to multiply L by d1 d2 with 4p by pi e. That will be the total deflection. So the total deflection value is delta is equal to 4p by pi e into L by d1 d2. Okay, so we can take it as this is equal to 4pl divided by pi e d1 d2. Okay, so this is the final answer of the deflection or deformation of the bar with varying diameter and having d1 and d2 at the two ends. Okay, so I hope that you understand the concept, and you know how now you know that how to do this derivation. So Please do subscribe the channel and share the video if you like it. Okay, we will see more videos in the next tutorials. Thank you.